All right, guys. So we're moving on to lesson 4, 5, unit 4, lesson 5, talking about ways to prove triangles are congruent. So there's many different ways: side, 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 angle, side, angle, angle, side, and hypotenuse leg. We are only going to deal with two of them right now: side, side, and side, angle, side. All right. So those are the only ones we're going to deal with for right now. All right. So reasons. This sheet is very important. Do not lose this sheet. You'll be able to use it for many different things. All right. So reasons sides are congruent. It's given. Definition of midpoint or reflexive property. Okay, those are main reasons why sides are congruent. Reasons angles are congruent. They're given. So it says that. Vertical angles, alternate interior and alternate exterior and corresponding angles. These must have parallel lines, and then definition of angle bisector, okay? So just a refresher on CP, CTC, so corresponding parts of congruent triangles are congruent. So if triangle ABC is congruent to DEF, then what? AB is congruent to what? AB is the first two, so the first two here is DE. All right. Then BC. So we have BC would be congruent to what? BC is the first two, or the last two, I'm sorry. So the last two here is EF. And then the last side would be AC, which would be congruent to what? AC is the first and the third, so the first and the third is DF. All right. Now for angles, just match them up. So angle A is congruent to angle D. They're both the first. Then the middles. Angle B is congruent to angle E. And then angle C is congruent to angle F. All right. So just a refresher there. So triangle congruent, side, side, side. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So just look at our tick marks. If AB is congruent to what? AB has one tick mark, so this tick mark would be DE. And then BC has two. So what other one has two? EF. And then AC would be congruent to DF. So if all the sides are congruent to another side in another triangle, then triangle ABC is congruent to triangle DEF. All right? So let's take a look at some sample ones here. Given. All right, so we're going to have to make our tick marks in different things. PQ is congruent to ST. So PQ is right here, congruent to ST. So I just put one tick mark for each one. QR is congruent to TR. All right, so I'm going to make those tick marks. And then R is the midpoint of PS. So if it is the midpoint, that means it cuts PS in half. So therefore, PR is congruent to RS. Okay, so let's take a look at our statements. PQ congruent to ST. Well, that's all in this line of given, right? So I'm just going to write given. What about QR and TR? That's up in that line. Given. R is the midpoint of PS. Given. It's up there. So then how do we know PR is congruent to RS? What was that definition? Def of midpoint. So that was on that first sheet. That was one of the reasons we could use for sides, definition of midpoint. So then they are all the same. Triangle PQR is congruent to triangle STR by side, side, side. All right, all the sides. Let's take a look at number 2. JL is congruent to NM. So JL and NM. K is the midpoint of JN. So it's the midpoint of JN. So that means JK and KN are congruent. And it's also the midpoint of LM. So therefore LK and KM are congruent. So JL congruent to NM, that's given. K is the midpoint. Well, that was the next line that they told us, so that was given. Now, how do we know that JK is congruent to NK? If K is the midpoint, that would be the definition of midpoint. What would it be for K, LK and K, MK? Definition of midpoint again. So then how are they? So what is our reasoning? If we have all 3 sides marked, it would be side, side, side. All right. Number 3, AC is congruent to AD. All right, so I marked those. And CB is congruent to DB. All right. So once one of the statements, AC congruent to AD, and that was given. And then CB is congruent to DB, given. They were both up there in that given line. Now, what are we trying to prove? Prove is going to be our last. So triangle ABC congruent to triangle ABD. Now, what part are we missing? We are missing this middle part, right? What we could say here is AB is congruent to BA, and that is called the reflexive, okay? Reflexive property. So just like looking in the mirror and you see your reflection, any line can be reflective upon itself, meaning that it is equal to itself. So now we have 3 marked on this triangle, 3 marked on that triangle, side, side, side. All right, moving on. Side angle side. If 2 sides and the included angle of one triangle is congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So included means in between the 2 lines that are congruent. So if the side AB is congruent to what? Which one has 1 over here? DE. Now we have the angle. What angle is it that is marked in between the 2 sides that we know? Angle B is congruent to angle E, and then the other side, so BC is congruent to EF. Then triangle ABC is congruent to triangle DEF. All right? So let's take a look at a couple of these proofs. Given JM is congruent to LN. So those 2 are congruent. Angle LMN, this angle right here, is congruent to what? JM. Okay. JMN, so this angle right here, is congruent to LNM right here, okay? So those are the things we can mark. So JM congruent to LN, that's in that line for given. And this one is also given. Now, how do we know that MN is congruent to NM? How do we know? What was that property that we just used that said that the same line is equal to itself? Reflexive property. So now, what way can we say? So we go side to an angle to a side, angle to a side. S, A, S. All right. Number 5, AB is congruent to CB, and BD bisects ABC. So ABC is this one. If it bisects it, that means it cuts it in half. All right, so we have everything marked. AB congruent to CB, given. The next part was given. How do we know that angle ABD is congruent to CBD? What is that? Definition of what? We're dealing with an angle, so angle bisector. Okay, definition of angle bisector, cuts the angle in half. Now, how do we know that DB is congruent to BD? What was that property if it was on the same thing? Reflexive. And now the triangles are side, angle, side, side, angle, side. All right. Number 6. V is the midpoint of WZ and XY. So if V is the midpoint of WZ, that means WV and VZ are congruent, and VXY, so XV and VY are congruent. So how do we know that that is? So that's given. That was given to us. How do we know that WV is congruent to ZV? Definition of midpoint. How do we know angle WVX, this angle right here, is congruent to ZVY? What type of angles are these? Vertical angles. So by vertical angles. Now, how do we know that XV and YV are congruent? Well, V was the midpoint, so definition of midpoint. And so number 5, what is our reasoning? Side, angle, side, side, angle, side. S, A, S. All right, number 7, given HI is congruent to JG, so JG, HI. It also says HI is parallel to GJ, all right? So how do we know the HI to JG? HI to JG, that's in this one, so that is given. What about being parallel? Given. Now, what angles are they asking us to use? G, J, H, so right here, and I, H, J, this one right here. What are those type of angles? They're on alternate sides of this line, dealing with parallel lines, so they're alternate. Alternate what? They're inside the shape, so interior angles, all right? So that's how we know. Alternate interior angles for those. Now, how do we know that HJ is congruent to JH? Right here. How do we know that? What was that property? Reflexive. Now, how do we know triangle GJH and triangle IHJ? Side, angle, side. Side, angle, side. All right, and then the last page, triangle congruency. Last page for this set of notes. Side, 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 angle, side. State whether the triangles could be proven congruent by side, 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 or side, angle, side, then write the statement. I'm not really worried about the statement right now. Let's just look at the congruency. So, side, angle, side, side, angle, side. So that would be by side, angle, side. What about this one? We only have two sides marked, but what can we say about AC? It can be reflexive. So one side, two side, three side, one side, two side, three side, 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 side. Number 3. So we have this big triangle, JMK, and then LMK. What side could be, what side do we use both on? MK, so side, big angle, side, side, big angle, side, side, angle, side. What about number 4? Yes, we have two sides and an angle, but is that angle in between the two lines? No, it is not. So it is actually not congruent. It has to be in between the two lines that we know. Number 5, EF definitely is reflexive. So side, 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 S, S, S. Number 6, again, we have parallel lines. So what does that mean? That means these angles right here on that transversal are congruent by alternate interiors. So side, angle, side, side, angle, side. What about number 7? Side, angle, side, side, angle, side. But is that angle in between where the two lines meet? No, it is not. So it is not congruent. And then number 8, what type of angles would these be? They would be vertical angles. And now it goes side, angle, side, side, angle, side. All right, there you go.